In this video, we're going to be doing some stoichiometry using some solutions. Like any other stoichiometry, you still need to identify the data, have a balanced chemical equation, know what is known and what is unknown, find the moles of the known, use the balanced chemical equation to find the moles of the unknown. But now you can now find a mass, a volume of gas, a concentration of solution, or a volume of solution as your unknown. So here is a summary of the stoichiometry. So if you have a concentration and a volume of a known solution, then you can find the number of moles using N equals CV. From there you can find moles known, moles unknown, and then if you're continuing to find concentrations or volumes of solutions, then you can use these rearrangements. Now let's watch an example using solutions for a stoichiometry. So in this example, the first thing we need to do is we need to identify our data, and we can see that we have 25 ml 0.15 molar calcium nitrate and we have 25 ml 0.12 molar sodium phosphate. You should be having some alarm bells go off at this point in time. Ding, 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 ding. You've got too much information. Too much information means it's a limiting reagent question. Now the other thing is we don't have an equation. So we must write an equation before we start. So we've got calcium ions and phosphate ions will give us calcium phosphate. I know this by using my solubility tables, that this will come out as a precipitate, and make sure that it is balanced. So now let's look at what our next step is. So looking at the information provided, we have a concentration and a volume of a solution. So this means that we can find the moles using number of moles equals CV. Now, like any other stoichiometry, we're going to find the mole. But because it's a limiting reagent, we've got twice as many moles to find. Now you can see at the end of the question asks for the concentration remaining ions in solution. So we're going to find the moles of each of the ions. So let's get started. We're going to start by finding the number of moles of calcium nitrate. And that is equal to CV. Our concentration is 0.15 and our volume is 25 ml. Remember, all volumes have to be in litres. And this comes out to be 3.75 by 10 to the negative 3 moles. Now, from there we can find the number of moles of calcium ions, which will be the same because there's only 1 mole of calcium for every mole of calcium nitrate, and the number of moles of nitrate ions. Now, if you look at the formula, it says there are 2 of them. So it'll be 2 times 3.75 by 10 to the negative 3, which comes out to be 7.5 by 10 to the negative 3 moles. Now we can also find the number of moles of sodium phosphate. So our concentration is 0.12 and our volume is 25 ml. Remember, it must be in litres. So this comes out to be 3 by 10 to the negative 3 moles. From here we can find the number of moles of sodium ions, which will be, according to the formula, 3 times as many. And the number of moles of phosphate ions, which will be the same as the number of moles of sodium phosphate, which will be 3 by 10 to the negative 3 moles. So now that we've got the moles, even though we've got 2 knowns, our next point will be to find the moles of the unknown, so that we can determine the limiting reagent. So this is where we're currently sitting, moles known. We're going to have to find the moles unknown using our balanced chemical equation in order to determine the limiting reagent. Now, because it's got too much information, we know this is a limiting reagent question. And the best way to try a limiting reagent question is literally just to try it out. So I'm going to try mine out pretending that the calcium ions is the limiting reagent. So I'm going to try with calcium ions. So I'm going to have to find how many moles of phosphate ions would be used in this particular scenario. So I'm going to say the number of moles of phosphates is equal to unknown over known times the number of moles of calcium ions. Now the unknown in this particular case will be the phosphate ions. The known is the calcium ions times by 3.75 by 10 to the negative 3. And this comes out to be 2.5 by 10 to the negative 3 moles. Now remember, we must ask ourselves the question, do I have enough phosphates? Now if you look at how much we said we would need if we used up all of the calcium ions, you can see that we've actually got 3 by 10 to the negative 3 moles. So we've got more. This tells us that calcium ions is the limiting reagent and the phosphate ions are in excess. So now we've determined our moles known, we'll be able to find our moles unknown of the precipitate. So we've now decided calcium ions is our known, and our unknown in this particular case is going to be calcium phosphate. So the number of moles of calcium phosphate equals unknown over known times the number of moles of calcium ions, which in this case will be 1 divided by 3 times the number of moles of calcium, which is 3.75 by 10 to the negative 3. And this comes out to be 1.25 by 10 to the negative 3 moles. So now we've got our moles of our unknown, we can find the mass of our unknown because we're going to find a mass of our precipitate by using mass equals number of moles times formula mass. So we've got our moles, so the mass of calcium phosphate equals number of moles times formula mass, which is 1.25 by 10 to the negative 3 times the formula mass, which I get off the periodic table, which is 310.18, comes out to 0.388 grams. Now checking significant figures, we've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So our answer is in 3 significant figures, 0.388 grams. Now we're going to need to find the concentration of the remaining ions in solution. So we're going to be using concentration equals N on V. We already have the moles of each of the remaining ions except for the ion in excess. So now our task is to find the concentration of the remaining ions in solution. So let's go through the list. There are no calcium ions, so the calcium ions will equal 0 moles per litre because they were the limiting reagent. There will be some nitrates, but they're spectators, so their moles hasn't changed. There will be sodiums. Their moles haven't changed because they're spectators. Now the moles of the phosphate will have changed because some of them have been consumed in the reaction. Now in order to find the concentration, we need to know the moles and the volume. So our new volume for this solution is going to be equal to 25 add 25, which is equal to 50 ml. So the concentration of the sodium ions is equal to N on V, which is equal to 9 by 10 to the negative 3 divided by 0.05, which comes out to 0.180 moles per litre to 3 significant figures. The concentration of the nitrate ions is equal to N on V, which is equal to 7.5 by 10 to the negative 3 divided by 0.05, which is 0.150 moles per litre to 3 significant figures. I'm now going to have to calculate the number of moles of phosphate ions in excess. In order to calculate the number of moles of phosphate ions in excess, we are going to need to find the moles unknown. This will tell us how many phosphate ions were consumed in this reaction. So the number of moles of phosphates used will equal unknown over known times the number of moles of calcium ions, which is our known. Our unknown is 2 over 3 times 3.75 by 10 to the negative 3. And this comes out to 2.5 by 10 to the negative 3 moles. So the number of moles of phosphates in excess equals the number of moles of phosphates at the start minus the number of moles of phosphates used. So this will be the start was 3 by 10 to the negative 3 minus 2.5 by 10 to the negative 3 is equal to 5 by 10 to the negative 4 moles. So now that we know the moles of our unknown, we'll be able to find our concentration of our phosphate ions using concentration equals number of moles divided by volume. So now that we've got the moles, we can find the concentration of the phosphate ions is equal to number of moles over volume. So the number of moles was 5 by 10 to the negative 4. Remember our total volume was 50 mils, so 0.05. And this comes out to 0.0100 moles per litre, so that we finish in 3 significant figures. Now I'd like you to try one yourself. Go to the OneNote, Solutions, Calculations, then there's a page called Calculation for you to try one out. When you've finished, I have put in a YouTube link here that you can see your answers, or you can go to Space and see the link from there. Good luck.